It is quite distracting.
Okay, only two people are there so far. It's me and there don't have profile picture. Right, that's so. I like using the touch bar for this thing. What flow?
Doesn't feel the need for a mouse.
Students who have joined online, I hope you can hear me and see the board. Can you confirm that?
Yes.
Yes, sir.
Okay. Okay. What's your name? Okay, so while we are waiting for more people to join, first thing first, Marto, सगळ्यांना मराठी कळतं का? I'll try to speak in English, but sometimes I may use a few Marathi words here and there, so please bear with me. I guess everybody must be attending school, some other classes, so you know the whole day has been busy for you and me as well. So first thing first, don't think of this as one more online class. Right? They are going to relax and enjoy. Okay. You will start to realize something that my mom always says that whenever I used to get bored of doing any other subject or school work, I used to do mathematics like a hobby. Now this might be a new question for you, that how can you do something like maths and next week you are going to do programming as a hobby? So how can these two be hobbies? Yes, you are already saying yes. So Siddharth already said, yeah, they are hobbies for me. And then maybe more of you also who think of these things as a hobby, but then how to develop that hobby constructively, how to apply what you learn in that for other subjects. So how to start thinking creatively. These are some ideas which are there in my mind. And this is the first experiment, to be honest. So I am also going to learn a lot of things in the process, and we will refine the material for the next version. So basically, you are all going to help me, in this journey. So that is how I look at this program. And next week when we do programming, I would expect everybody to bring a laptop, because again the thing is that I will be teaching as if you are doing programming for the first time. Some of you may already be somewhat experienced in programming, and if that is the case, do let me know in advance, so that when I'm doing something very basic, I will give a bit of something more advanced to you, so that your time is not wasted. Okay. So maybe you can just drop a message on the group or send me a message later on explaining what is the So I learned the first thing that in the first lecture you have to wait for 5-10 minutes because people are still arriving. But we'll spend some time or some way to kill time. So what can we discuss? What is your experience? So you said you like programming, maths as a hobby.
Maths.
Is it a काय करतोस?
मी आधी एम प्रकाशच्या घरी जायचो
Okay.
आणि ते मला थोडंसं शिकवायचं, तेव्हा मला ते आवडून गेलं. आणि मी आधी बाबाकडून शिकवायचं तेव्हा सिलेक्ट केली.
तेव्हा असं काहीतरी मॅथ्स मध्ये इंटरेस्टिंग तुला वाटतं का की हे छान आहे, तेव्हा आवडलं, म्हणजे असं तुला काहीतरी एखादी प्रॉपर्टी किंवा काही तुला लक्षात आहे?
And
Sir, good evening. My name is Ruby.
Hi Dhruvi, you want to share something? If you enjoy mathematics as a recreation, by the way, for those of you who can enable your camera, that would be good, because in the hybrid mode it becomes easy for me to interact with you. So yes,
Sorry, sir, your voice was breaking a bit.
sorry, can you repeat that?
Your voice was breaking a bit.
My voice is breaking a bit. Okay, I'll try to repeat whenever there is any audio issue. Okay, just let me know.
Yes, sir.
Yeah. Generally speaking, this classroom has been used for online lectures for 2 years, so I think the internet should be stable. But if we have any issues, we'll try to fix them.
मी जेव्हा त्यांच्याकडे जायचं मी मला 1+1+1 असं आणि फॉर्म्युला शिकवलेला आता फॉर्म्युला शिकवलेला
बरं
आणि जसं स्क्वेअर आणि क्यूब पण शिकवलं.
बरं. मग क्यूबच्या पुढे काय करतो?
क्यूबच्या पुढे त्यांच्यामध्ये जायचं.
Ishan, somebody is waiting for a link.
अजून कोणी मॅथ्स मध्ये काय करतो? या शाळेतलीच एखादी असं नाही की तुम्ही स्वतः काय केलं असेल समथिंग विच यू लर्न इन स्कूल विच यू फाइंड इंटरेस्टिंग इन मॅथमॅटिक्स. Whether which standard are you all in? Achita?
6.
Okay. Can you repeat your name? Adit. 6. Online, can you tell me which standard are everybody in? Kevin?
Sir, I'm in 6th standard. My name is Daksh Taneja, and I used to code in code.org.
Okay.
I used to make games like Minecraft in it,
Okay.
and I used to make apps like if you touch the basketball, so it will throw it away.
Okay.
Uh,
Which language did you do that in?
It was Blockly language.
Block. How about somebody else? Arush?
6th grade, yeah. I do a little bit of coding. I like maths a lot.
Okay.
I code. Now in Scratch, I'm trying to do a platformer with like a player, and you jump around the different things, and you
Okay.
go and moving platforms. And
What are you saying?
Anybody else?
Pardon me?
Anybody else who would like to say anything
You're
interesting?
not able to hear me.
Sir, can I say?
Yes, who is speaking? Rajesh, are you speaking?
Now can you hear me?
Yes, sir,
Okay.
you can hear you.
Yes, yes. I already know a bit of information about you, so we'll come to you later. Anybody else?
Sir, in
Sir,
maths,
can I say?
sir,
Yes, go ahead. Daksh?
yeah, sir, in maths, I like to do logical work, but not in calculations, and I'm very good in logical work.
Logical work. Okay. So we'll try to find out what
You
that
did
means.
lines and angles?
Lines and angles.
Yes.
Huh? Sorry, not to you.
Sir, I like to construct lines and angles also. It's a very interesting chapter.
I see. Okay. Okay, so I think we start. We are already in 3 minutes. I'm sorry if anybody else is joining. So also I hope everybody can see the board. And those who are not speaking, can you just mute the audio so that when you are speaking, you can unmute yourself. Okay. So we'll start. So let me just give you some idea. I already talked a bit about what is the purpose of the workshop according to me. But just to give you some more idea what this workshop can be about. So maybe first thing first, what is mathematics? If we try to explain in our own words. If I write a sentence such as in the mind and try to use as few words as possible. Ideally 5 to 7 words at most, not more than that. So try to write your own definition. Hello. How do you describe mathematics in your own words? And the same question can be asked in so many different ways. I can ask you, write just one word. Mathematics is dash, only one word. Then your response will be different. If I ask you, write 3 to 5 words, then your response will be different. If I tell you, write one essay of 10 sentences, then your answer will be different. So the first thing you have to understand is one question does not have one answer. There are so many variables in the picture. The way you approach that question changes your answer. Okay. So the very basic question is not so straightforward. What is mathematics? And I would like to hear what everybody thinks. Has anybody written down anything? Take your time. But don't take too much time.
I would say mathematics is fun for me.
Who is speaking? Kevin?
No, Kavin, I'm saying
Mathematics is fun for you. Yes.
it is fun, but
Okay.
it's also an abstract way for solving problems. An
Sir,
abstract way for solving problems. Something that we think.
sir, mathematics is a world of calculations and logical thinking.
The world of calculations and logical thinking. Okay. So the more words you use, the more verbose you can be. By the way, we have some new members. So can you tell me your name and standard? You can say come here. Oh, you are? Oh, good to meet you. So you can see on the board. I'll just written one question. What is mathematics? Mathematics is that fill in the blank. So try to write your own answer and don't use too many words. Maybe 5 to 7 words ideally. And you may also wonder why is this question important? Mathematics is whatever the teacher teaches us is mathematics. Why do we have to think about what is mathematics? So one of the purposes of this workshop is that I want to highlight the difference between process and outcome. What is the meaning of process and outcome? Yes.
Process is
Did everybody understand what he said? But let us use some example, to understand this better. So how many of you like watching some sport, maybe cricket?
yes.
Okay, 2 people. Football, anybody who likes football?
Yes, sir, I watched the World Cup.
You watch the World Cup, okay, great. Or maybe you like to watch some movies, anybody? Okay, great. Something like Marvel series, anybody likes Marvel? Okay, great.
Yes, sir. Yes,
So,
sir.
right now there is India, Bangladesh, the ODI happened. It didn't go very well for us, but it did happen, right? So suppose I tell you that finally, I didn't see the match, but suppose India, what 200 for 4 and Bangladesh 199 for 3. And so India won by 1-1. Okay, I tell you this final scorecard. Will you get the same level of enjoyment as watching the match if you just look at the final score?
No.
I told you the score, right? So you know what happened in the match. But is that the thrill or watching every over, watching every ball?
No.
How it's sometimes it's a very nail-biting finish right of the last ball. That process is important to really appreciate cricket. Same with movies. I can just tell you what happens in the last half an hour, reveal the mystery. But is that the reason why we watch the movie? No, it's the process of arriving at that conclusion, which is the interesting part about the movie, right? So in school or any other exam that you're solving, you may be asked a question like this, maybe one object cost rupees 80. So then find the cost of 23 objects. Okay. So this is the question that you are asked in class. I think everybody knows how to solve the question like this. So what will your answer be? Like what will your solution be? Maybe
23 into 18.
23 into 18. And how much is that answer?
414.
414. So starting with the question, everybody knows how to read the solution. And is this mathematics? That's what we know, right? We do a lot of examples like this in mathematics. But this is exactly process and outcome. See, this was the outcome that you know that you solve this problem with this method. Or even within that, you have this method of multiplying two numbers, which that to cross two tables. All of that is the outcome. But do you think it happened like one day some prehistoric man suddenly woke up and oh, this is how we multiply numbers? There was a process, right? Somebody who was drawing something on the cave wall, and one by one, step by step, that whole logic got developed. So what you are watching is just the climax of the movie, or scorecard after the end of the match. But you didn't watch the entire match. Like, how did you arrive at this method? And why is this the answer to this question? And that total process along with the final method is mathematics, not just the final answer. That is the difference which I would like to illustrate through this workshop. Again, I don't want to just tell you that this is the answer and that's all, end of story, go home. But we'll discover that this is how mathematics works through the 5 days of mathematics, and similar thing for programming also. Okay, so that is how we will look at this. So instead of going from question to the solution, we'll follow a slightly different approach in our treatment of every topic. Okay, so let me draw the diagram. Right. By the way, first thing I'm learning, every time I look around for the duster, because that is the traditional habit, right? You just go to the duster, but on the hand is the duster. So this is how we can think about it. So we first ask the question. So that's the starting point. You ask a question. And then what we saw is that there is some solution. Apply and solve some solution. But instead of going from the question to the solution directly, what we are going to do is this. After you look at the question, you start doing some small experiments, try different ideas, and explore what we can call patterns. Okay, so from here we first explore and observe patterns. So this can be different kinds of patterns in different questions. Then once we have guessed some pattern, okay, maybe this is how it works. Then we need to develop some tools to solve. For example, multiplication was a tool.
Excuse me, sir.
Yes.
Sir, we cannot see the IPT. So can you bring the camera a bit closer?
Oh, sorry. I think I made a mistake here. Can you share my? Are you able to see the screen directly? Because I'm sharing the screen.
Yes, sir.
So
We can see.
You're looking at the camera view, but you should switch to the screen view. Does that make sense? Baba, the screen display na?
Yes, it is.
हॅलो
visible.
एक मिनिट थांब प्रशांत
हा, बघा.
चेक करतो
बरं.
व्ह्यू ऑप्शन मध्ये
स्क्रीन दिसली पाहिजे.
सर स्क्रीन दिसते.
दिसते ना?
तू
हो.
कुठून बघायची स्क्रीन
कशी बघायची?
सर स्क्रीन शेअर वर ते स्क्रीन शेअर त्याच्यामध्ये स्क्रीन दिसते.
पण मी ते शेअर केले.
शेअर स्क्रीन
नाही.
हा.
म्हणजे
नाही नाही शेअर स्क्रीन नाही
ठीक आहे ना? ते चालू आहे.
व्ह्यू मध्ये साइड बाय साइड स्पीकर
मी माझा मोबाईल
हा साइड बाय साइड स्पीकर ओके प्रशांत आय कॅन सी नाव
Okay. So I think I've
Sir,
done right.
it is blur.
It is dark, but can you read the letters? See.
No,
are you
sir,
seeing
it
the
is
view
quite
where-
blur.
Are you seeing the view where I am also visible and the screen is also visible side by side? Then you are looking at the camera. So you should not look at the camera. In the participant list, I will be also there in the form of directly you can see the screen.
ऑन द राईट साइड व्ह्यू इनसाइड व्ह्यू यू हॅव टू क्लिक साइड बाय साइड स्पीकर
Oh, okay, sir.
See if you can find it. Otherwise, let me know. Okay.
Yeah, it is working, sir. Thank you, sir.
Okay, great. Thank you. One more thing to learn for us. Okay, so we ask a question, then we see some patterns, then we have to develop a tool. Or develop some tool. Sometimes more than one tool has to be developed. And then we use that tool to solve the problem. Okay. And then what do we do? Question some. Trying in different ways for find new solutions. Very good. What else?
Find the formula.
Find the formula. Okay, very good. What else can we do?
Cross-checking.
Okay.
Proving that this is correct.
proving that.
Construction.
We did all of that. Then what do we do?
Think of some other pattern.
Think of some other pattern. Now, why not we do this? Ask a new question. There is only one rule that you have to follow in this workshop, that when I ask a question and you give me a solution, the end of your solution should be one more question. Okay, that is the only rule you have to follow in this work. So, how do you construct a new question from a given question? You know, we completely reverse the flow. पहिल्या diagram मध्ये काय होतं, question, answer, full stop. We don't go like this at all. We just keep going round and round. Question, solution, another question, another solution. The obvious question is when will this end? So first thing, note that it's not a circle. Actually, it's like a spiral, because every time we'll be asking a new question, which is bigger than the original question. So we are not going round and round in circles. We are actually, going like this really. Every time we ask a new question, we are expanding our, horizon. So with that in mind, this is how I will try to answer this question. Mathematics is what? That. This is my interpretation of this. Mathematics is a spiral, okay? That is one possible answer. Maybe I'll write something like this. But by the way, please note this diagram, because it's very important to the way we approach everything. So while you are noting the diagram, let me practice writing on the board.
Study of numbers.
After a lot of fun, this is the least number of words that I require to fully describe mathematics as I understand it. So firstly, it's a creative process. It is not something that the teacher tells you that this is mathematics and we'll do that. We are going to create our own mathematics. So that's why why did I call this workshop creative? Because the word creative is the most important. You are going to create the mathematics in the days to come. Creative process, by the way, the word process is very interesting there, because we are going to do programming in next week. And I don't know if any of you are aware that the word process has a different connotation in the computer world. So it's interesting that you already find some connection between mathematics and programming, of exploring patterns and reasoning about them. Yes. So is saying anything?
This area, explore and observe patterns, develop
Explore and
tools.
observe patterns. Correct. So actually, I took bits and pieces of everybody's definition, because somebody was talking about logical reasoning, somebody was talking about numbers, patterns, things like that. So it's a mix of everybody's definition. So we are going to spend some time to understand this pattern. What is a pattern? What is reasoning? We'll understand all of this through examples. I don't want to bore everybody with just theory. So maybe let's think of one pattern. So everybody knows how to multiply numbers, right? So
Yes, sir. Multiplication, you can think of as the addition, again and again, repeated addition.
repeated addition. So let's multiply two numbers. Okay, let's start with 3. So let's multiply 3 with itself. 3 into 3, 3 into 3 into 3. We'll keep doing that. Okay, so what will the answer is that we get?
9.
9, 27, 81,
27, 21, 243, 729, 1287, 6,000.
561. Very good. Keep good. Very good. So you know a lot of powers of 3. That's very good. But what else do you know about those powers of 3? That is the question. So let's write a few numbers maybe. Can you write a few examples like this? See how far you can write.
So 729.
Let's write one more term. Okay, so 729 into 3.
So
2187. I said 1 2 by mistake. It's 2187. I said
And so on and so on. So we can write few more terms like this. Okay. So why did I write that number? Where does now come?
I'll figure out the pattern.
Okay, you have some pattern in mind. Wait. First thing, let us give everybody a chance to answer, because somebody can think of the idea quicker, but everybody should have some time to think of the idea. So if you get the answer, try writing it in your notebook, and I'll come and check. And those who are online, if you get the idea, try typing it in chat, and I will take a look. Okay.
what should we write in the chat?
I don't know. If you observe something, you write it. If you don't observe anything, then try to keep looking. There is no question. I've just written some numbers on the board. And he says, raise my hand, I see a pattern. That's what he said. So, I don't know. Maybe there is a pattern, maybe there is no pattern.
Answer the number.
Okay, so can anybody tell anything which you observe? What about the last place, the units place digit? Yes.
397. There's odd number.
Yes.
There's 1379 always. 1379 always.
So they are in a pattern of 3971 and it keeps on repeating until the end of the.
397.
What do you want to say?
Sir, we've already done that.
These are all divisible by 9. Okay, correct. Anything else?
So,
The pattern for us to wait for it.
Okay. Can you please?
oh, can you hear me?
Yes, go ahead.
So if you can see, the last digits are all in a pattern 3971 and it keeps on
3971.
repeating. So
Yes.
because essentially after 1 it becomes 3 again. So and then after 3 it becomes 9, then 7 and so on. So the pattern of 3971 will keep on repeating until the end of the number system, if there is any.
If there is any, was very important. Yes, but I think everybody is observing the pattern. The last column is 397. Yes, sir. Some of all the digits is visible by 9. Correct.
And on left hand side also 397.
Which left hand side? Left hand side. This. So this is I just copied the number, right? This 9 are written here. So whatever pattern will be here also, right? But yes, everybody understands that this, if I just look at this column, right? It seems to have only the number 3971, 397.
Yes.
To wait for 2 wait.
Sir, 1 second.
Oh, please don't write on the board. If you have anything, or at least raise your hand so that I give you permission to write. Is that fine? Ideally, in offline plus online classroom, one way which I can recommend is that you write in the notebook and have your camera above the notebook so that I can see what you're writing in the notebook. Okay? That is
4284. 4284.
4284, maybe. So the question is that. Yeah. So we are observing a lot of patterns, but just because we observe a pattern does not make it true, right? Because we just wrote how many 6, 7 terms on the board. But how many numbers are there in this whole sequence? Infinite, or definitely very large number. I don't know whether we want to call it infinite or not. But certainly we cannot check all of them. Even if we sit here for the whole day, 24 hours, If you even put a computer to work, computer memory will also run out after some point. So we cannot, how can we be sure whether what we are observing is correct or not?
So we can, so can I say?
Who is speaking?
So Arush.
Yes, go ahead.
So we can state this by proving our hypothesis by using some methods. So a proof is essentially a step-by-step method to that concludes that your hypothesis was true. So
Okay.
essentially we can prove that since this pattern of 4 always so after 3 you always get a 9, then a 7, then a 1.
Mhm.
Because when the last is 3, so this last digits only depend by the previous last digit, which is essentially recursion algorithm and programming, sir. So I believe you might know. So this is essentially kind of
So
So-
see, I think what you're saying is essentially correct, but how can you say the same thing in as few words as possible? So what he's saying is that this pattern will keep repeating because after 3, 9 will come, after 9, 7 will come. That is what he's observing. So basically 3 3s are 9, 9 3s are 27. So then that will end with 7, and after 7, 1. So because of this way of appearance, your always the last digit will be one of these 4. Everybody understand this?
Yes.
Okay, so that seems to be a good idea, but can there be any other reason why no other digit can occur? For example, why cannot we have some entry which ends with 2? Can 2 be one of the last digits here? Yes,
No, sir, it can't be because it should be divisible by 3.
right. It should be divisible by
Excuse
3.
me,
So
sir.
we have numbers which end with 2 and divisible by 3, like 12, for example.
Excuse me, sir.
Yes, Siddharth.
And it should be number of the 3971.
Yes, that's what we want to explain. So why is that?
Excuse me, sir. Excuse me, sir.
Yes.
A 2 cannot appear in the powers of 3 table because the powers of 3 multiplied by 3 is an odd number, and any odd number multiplied by 3 is an odd number.
Right.
So,
So yeah.
an even number, it cannot appear in the powers of 3. Because for the last digit to be a 2, the previous term has to end in a 4. And for the previous term to end in a 4, the term before that has to end in an 8. And
Yeah, that cycle will keep going on, right? Yeah, for another. So you see, what he's saying is that every time you are multiplying an odd number by an odd number, so the result will be an odd number. So odd into odd is always odd. That's what he's saying, and therefore 2 cannot come at the last. 2, 4, 6, 8. All of those are ruled out because of this fact. Odd into odd is odd number.
Now I don't avoid other odd numbers.
Yes.
Which are the odd numbers? But before that, yeah, 5 should have come maybe. But before that, even this thing that we have just written odd into odd is odd. Again, the same question. How do you know that this is true for all natural numbers? Odd into odd is odd. So from one question there is one more question, and from there is one more question. Yes.
I know
odd.
Okay, so we'll answer this question in another class, okay? Because this is not a very simple question. There are many things that there are behind that question. Okay, so we'll come to this later. But what I'm showing you is that there are multiple ways of approaching the problem. See, one way was we just noticed the cycle of 3971, and that was the end of the question. We saw one more approach that why 2 cannot occur, 2, 4, 6 cannot occur because they are even numbers. And similarly, if you just think a little bit, you will also see why 5 cannot occur. So there are multiple ways to approach the same question. Okay, so that is about the last column. What about the column after that? 284, 284, 284. Will that happen? Are you sure? Just write one more number after this. Let's see what happens. So 729 into 3 is 207. 207 into 3.
Sir, 661.
61.
661. 661.
So there's not 284, 282. Suddenly a 6 has come there. So just by writing 5 examples, we cannot be sure that it will be 284, 284.
Then you have to do
Yeah, then just by writing 6 examples, we cannot come with any pattern. But suppose we continue writing a few more examples. Let's say there's some other pattern in the tens place. Look at the tens place for a few more examples. So 284, 286. Continue. Try to work this out in your notebook. Write a few more examples and see if you observe anything. You will know the pattern after this. Then try it in your notebook if you see something. Answer of what? But what was my question? My question is not what the next one, but the question is there any pattern or not? If you keep writing a few more examples, I think you run out of space on your notes. You can go to the next page and see again. Yes.
There are even numbers in this tens place.
Okay. Even numbers in this. Okay. So somebody is saying there are even numbers in this. Yeah, we can see there are even numbers.
The next numbers are 4, there are 6, 6561, and 19683, 59049, 177147, and 531.
Okay, so I'm not interested in the whole number for now. I just want to focus on the tens place column. So do you observe anything there? That is the question.
Yes, there is 6, then 8, then 4, then 4, then 4. 4, then 4, then 4 comes.
So everybody is observing this that the digits seem to be 2, 4, 6, 8 in some order, right? Only these 4 digits are occurring again and again. There
Even
is
number.
6 in every place. So one of these 4 digits is occurring 2, 4, 6, or 8. Or actually, if you think about it, there is 0 also, right? Here. First 2 were like there was 0 there if you didn't try. So basically, what is the observation that the tens place column is always an even digit?
Yes.
Do you agree? That tens place is always even.
Tens place is always even.
Yes, sir. And the ones place is always 3971, 3971, 3997 will go down. It
Unit
never
place is
becomes
always
even.
odd.
That part
Unit
never becomes
place
even.
And tens place is even. Okay. But these are our observations from few examples. How can we be sure that this same thing will happen for very large number?
So there can be no very large number. Very large number is like numbers are infinite, so we can't say there's very large number.
Yeah, numbers are infinite, but so how can we be sure? Because we cannot check all the infinite numbers, right? See, at most what we can do, in fact, let's do this. We are calculating on paper. We can take help of maybe a calculator or something like that. Do you know the most powerful calculator?
Yes, sir. So those are supercomputers. So they can like calculate 10 to the power like many things by quantum physics, I believe.
Yeah.
Excuse me,
Exactly
sir.
how that works. If you
Excuse
want me to
me,
explain, I can know exactly how that works. I can explain on my own also.
excuse me, sir.
Okay.
The proof is that. Stop sharing his screen.
Yeah, I'll just share it again in 1 minute. I'm sorry, you're not very much stop button.
So if you want me to, I can explain exactly how it works also. I designed my own. I didn't
Excuse me,
get it.
sir.
Yes. So the most powerful calculator for us is Microsoft Excel. So let me share the screen again. Just give me a minute.
No, sir, you have not shared it.
Yeah, just 1 minute. Can you see the spreadsheet now?
Yes, sir.
So why don't we do this instead of doing this on
Yeah.
paper? Let's start by So the next power has to be 3 times this. So in Excel, you notice that I can say this is this into 3.
Yeah.
That is 9. And so the command here given is that this cell should be the previous cell into 3. Correct? So what can I do now?
Just write it down.
Yes.
Write it down.
So everybody knows that how to feel.
Type 27.
Yes, just write it down. Write it down. There it is.
And we
You see
continue
now,
talking to
instead of
great
calculating on paper, we can just see what's happening here. And can we drag it more also?
Yes, sir. Yes, sir.
So you can write it more.
So now you can see the pattern. So now it's very easy to see the tens place column for at least 10, 20 values you have observed it that it is all even digits. Do you see that?
Yes, sir.
Okay. So in the next week we are going to see how mathematics is useful for programming. But now what I'm showing is how programming can be used to do mathematics, easily to some extent. Okay.
Excuse me, sir, Microsoft's calculator can find whether the value like super big numbers like pi to the power of pi to the power of pi to the power of pi and without the parentheses.
Yeah, so basically, yeah, finally Excel will also have some limits, but definitely more than what you can calculate on paper, right? But I should warn you that when you're using a tool like this, there is a great saying: with great power comes great responsibility. This is a very powerful tool, but we should be careful to use this tool so that we don't end up forgetting how to do things on paper. So I will trust you to use it correctly. Whenever you want to find some pattern quickly, you can use something like this. But that does not mean you should not use paper sometimes. Okay. But be aware of these tools because if I don't tell you, you are going to find out anyway. So might as well show you how to do this. So yes, there is a pattern looks like, but now the question is that just because we checked it for some 30, 40 numbers maybe, why is that going to be true always?
Yeah.
Why is that going to be true always? That is the question. One's place is fine. That at least we got some explanation. But for the 10th place, we don't have any explanation so far. We just observe that it is happening.
Excuse me, sir.
Yes, Arthur, if you found the answer, can you just write it in chat so that everybody gets a chance to try it? Or you can write in your notebook and show your camera, okay? So I can read what you have written.
Okay, so
Okay, so returning back to our board. Okay, so coming back to the board. So we observe the pattern now that the test place is even. But now we have to develop some tool to help us through this. So what can the tool be?
No.
See, every number, if you give me any number like 243. You see, I can write it as the tens place and
75 is the answer.
So for example, 24 and 3 can be separated. So I can write this as 24 times 10 plus 3. Correct?
Yes, sir.
And any
Understood the
number,
mistake?
any number
You have
how
to do
smaller
x minus 30. So answer will be 75.
बाबा तुमचा म्यूट करता का माइक which will be divisible by 3?
And, the even numbers.
Okay. No, I didn't fully understand what is your logic. This part you understood. That 2 part can be written like this. So any number, let's say in this list we have some number n. So that number n can also be broken into the tens part and the units part, right? So if that n has some digits a, b, c, d, e, f, g, h, whatever, we don't know. So if I just split it here, I'll get a tens part and a units part, correct? So in general, if I represent this tens part as some t, so t is that part which is from the tens digit onward, and u is the units place digit. So what will the value of that number be in terms of t and u? 10t plus u, correct? Because here it was 24 into 10 plus 3. In general, any number can be written as 10t plus u. Correct? Okay. And now what we are saying here, can you interpret what is the plane in terms of this t and u? Because for every term, if you write the value of t, it will be the last digit of t will be this 10th place column, right? So what we are saying is that this t is always an even number, right?
Excuse me, sir.
Yes.
I wrote what I've done here.
Okay. Can you hold it up a little bit? I cannot see it properly.
Yes. For 3971, 3 at 10th place is always 0 or 2. And since all the numbers end in 3971 and we've shown that, then here even into even is even. Like even into 3 is even, not even into even is even. Even into 3 is even, I meant to write. Sorry, even into 3 is even.
Actually, Aslam, I cannot read your notebook very clearly from here. So can you type in the chat that I can
Yes,
read? Okay.
Okay, I'll write in the chat.
Yeah. Okay. So if you look at the tens column, for every number, if I write the tens and units part, so here the first entry, the tens part is 0, 0, 2, 8, 24, 17. So what I'm saying is that the tens part is always even. You see, that is what we are saying here, that the tens part is already even. So now suppose you take a number like 10t plus u, where this is already even. Okay. And now when we come with the next entry in our list, what do? We multiply the previous one by 3, correct? So if I multiply this by 3, what will happen? 33 plus 3. 33 plus 3. Okay.
3 plus 3u.
Okay. Then what will happen? Now this 3u part is interesting because depending on the value of u, you know how multiplication works. Sometimes you have carryover, sometimes you don't have carryover. So if and we already know that you can take which possible values 1, 8, 7, 9, correct? So in which cases there will be no carryover.
So 3u is
1 and 3. 1 and 3. So if u is 1, then 1 into 3 is 3. And if u is 3, then 3 is 9. So in these two cases, there will be no carryover. And what about the other two cases?
so there'll be carryover of 2.
Okay, so if u is 7, then what will the carryover be? 21, right? So 2 will be carried over. So in the case of u is equal to 7, the carry is 2. And what about u equal to 9? 8. 8, 9. Sorry. Again, 2, correct? 9 is 27. So you write 7 below and carry over 2 again. So this is interesting that in the case of 1 and 3, the carry is 0. And in the case of 7 and 9, the carry is 2. So do you see that in every case the carry is always even? So when you do multiplication like this, Let me erase this for a while. So if you have a number like 10t plus and you multiply by 3, okay, so then this 10t becomes 30t, or 30t can be written as 10 times 3t plus 3u, correct? And now what we are saying is that this 3u can add a carry of 0, plus 0 or plus 2. So now do you see that if t was even, right? T was even. So 3t will be also even. Even number into 3 will also be even. So this is also even. And that to even number you are adding 0 or 2. So what will happen again? Even number plus 0 is the same number, and even number plus 2 is also even. So do you see from the previous case where the p was even, the next entry will also be even. And will this process keep on happening? Okay, and the only reason why this is happening is because u can be 1379 only. Do you see that if you were allowed to be 5, then this will not happen? Because if the unit place is 5, then 5 3s are 15, then the carryover is 1. And then your even digit will become an odd digit. But only because u can be only 1379 is this process continuing. Okay. So do you see how we started the question? Okay. So the question was, look at the powers of 3 and see the pattern in their digits. So then we saw some patterns such as the units places or the tens places even. Then we tried to come up with some tool like this, like how you represent the number as 10 place plus unit place, and that tool was helpful for us to solve the problem finally.
Excuse me, sir, I've done the problem in the chat.
Okay, let me check this.
No.
Just give me 2 minutes. I'm joining the meeting from my laptop. Okay. So after you solve the problem, what do you do next?
We asked another question.
Okay, so we did this for powers of 3, but is there anything special about 3? Maybe some other number has the same property.
Other numbers such as all the numbers from 0 to 9.
All numbers will have this property. Are you sure about that?
No, sir.
No, sir, some numbers.
So the square of 9 will have it.
81 in case
9 1. So for 9 it's 9 1 9 1. 4 it's 4 6 4 6.
For a minute. Can you repeat your name? So Brahma has a very interesting observation.
Okay,
Table is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Wait.
And in the 2 times table, it's 2, 4, 6, 8, 0. In the 3 times table, it's 3, 9, 7, 1. In the 4 times table, without looking at the tables.
Yeah, so see, that is a lot of information, but what is the pattern that you're observing?
1,
So
1, 1, 1, 1.
Mumbai indicated one very interesting observation that what we found for 3 will also be true for 3 square, which is 9.
9.
Why is that? Because the powers of 9 will be there in the powers of 3 itself, right? Because
9,
9
1, 9, 1, 9, 1.
is nothing but 3, 4 times. So just by proving the fact for 3, we automatically proved it for 9. We don't have to prove it separately. Yes.
Sir, can you power of 3?
Every single power of 3, that is correct. So if that property is true for 3, it will be true for 9, for 27 also, for 81 also. So you see, by proving one property, we actually have proved infinitely many properties. We have shown something in the table of 9 also, 27 also. But apart from these numbers, can there be any other numbers?
Yes, sir. There
13.
There can be many numbers.
2. So should I tell the pattern of 2?
13.
Arrows?
No, right. So what I'm going to do is that, see, because we have to move on to some different topic. So finally, we have to stop asking questions in the class. And this is your homework, that ask all the questions, find all the patterns you can find, try to prove them, maybe first cross-check them using Microsoft Excel, no problem. But then after that, you have to prove it. Because finally the Microsoft Excel sheet will also end after a few rows. How can you be sure that the pattern will continue after that? Okay, so these are all open questions. And so by the way, those who have registered have enabled access to the online material where all of these like bonus questions are there. Okay, and your job is to look at those bonus questions and see, and that is the starting point I am giving to you. After you solve that bonus question, you have to ask your own bonus question. Okay, and see any material that you send to me, I'll be very happy to read. Okay, so keep exploring it that way. Yes, Pranay.
So, the cube of 9 and 3 is divisible by all these numbers.
Cube of 9 and 3, they will also be powers of 3, right? So they will also come in this table somewhere. But apart from these numbers, if there is any pattern, that is what I'm interested in. Okay. So go ahead and make your own discovery now as homework. Okay. But I hope you understood how we can, take a small problem and keep improving it, keep evolving it, and try to complete many problems starting from one problem. Okay. So
Solution and another question.
sorry.
Solution. You find the solution to one question, then you ask another question.
Exactly. You keep doing that. Okay. Okay. So then, but here by solving this question, right, we actually use a lot of tools which we sort of knew were true because we maybe studied them in school, or you just think that has to be true. But one question I want to ask: what is 3? Just as I asked you what is mathematics, let's try to answer what is 3.
Can I say a suggestion?
No, wait. So let me frame the question properly before you answer. See, the challenge is like this. Suppose anybody likes science fiction, aliens, that kind of thing. Okay, everybody is raising their hand. Suppose tomorrow we meet alien civilization. Okay, and your job is to communicate to them something very simple, like 3 plus 3 is equal to 6. But unfortunately, they don't understand our language. We don't understand their language. But you can draw pictures and send them pictures. Okay? So can you draw a picture which you think will tell the alien that 3 plus 3 equal to 6? Okay, so try drawing this in your notebook, everybody. Can you draw a picture which will show the aliens and they'll understand? Okay, 3 plus 3 equal to 6.
3 9 was 3 9.
Drawing them.
Can I say?
Kevin, yes.
Yes, sir. So it's actually covered. It's covered.
Wait. Give 2 minutes for everybody to try. Okay, then I'll ask you.
So could I answer after Kevin?
Okay, I'll ask you then after Kevin.
Coven is Coven, please. Coven.
Oh, Kevin. Yeah.
Oh, sorry. I'm just observing your drawing. That will be But I really want mangoes. You can use something simpler, right? Okay, 3 aliens plus 3 aliens. That is very clear. But we need to know what both aliens look like. And so when you are at work, I want to ask for this. Into a guy.
Three circles plus 3 circles is 6 circles.
In fact, sorry, somebody was saying something? Yeah, I can see Athar's notebook, 3 circles. Okay. What are those circles? Are they some like object like fruit or basketball?
An object. I just made a circle.
Okay.
It means each circle is equal to 1 unit, so that's why 3 units plus 3 units is.
I can see Kevin's notebook is drawing. Are they people or aliens?
What I did was, I just showed that Imagine these are aliens. So I said 3 aliens plus 3 aliens is how much?
Okay.
So I just put the alien next to each other and then I show them all joined up. Imagine that's the answer. Because they don't know what plus sign is. They don't know what a plus sign is.
So many people are drawing aliens, 3 aliens plus 3 aliens.
So, can I tell what I
Roman
believe?
numerals. Okay, but I also don't know Roman numerals. How the aliens know Roman numerals? Okay, anybody else?
I believe, so I believe our crux of maths is defined on a simple base that we all understand. So if the alien civilization were to understand something, they would have to have a language to progress so that they could communicate to each other and have a base. So they would have to have a number system that might be different from ours, but essentially if we understand that number system, depending on how smart they are, then we could probably explain them in their own number system and communicate to them by their own knowledge that they already have. But on the other side, if they are not smarter than us, instead they are not as smart, then probably we'll have to essentially do something that is like that hasn't been done till now, that is essentially like creating an entire like humans that we have become.
The question is very simple. How to show 3 plus 3 equal to 6? In your
So like I don't think we can actually show it to them until and unless they know the basic crux of math. So we like
See, I think this is the problem I have with all of your approaches. Let me just summarize what I saw. So somebody is drawing maybe 3 circles plus 3 circles. Or somebody understand that we cannot show the plus sign, so just there is no concept on that. Or somebody drew an alien. I will not try to draw alien here because my drawing is bad anyway. So I just write 8. So no 3 aliens and 3 aliens. They form 6 aliens, something like that. Okay, something like that. Everybody is trying. But the basic question is maybe looking at this diagram, the aliens will understand, okay, 3 circles plus 3 circles is 3 circles. They will ask, what about squares? If somebody is drawing 3 squares plus 3 squares, will that also be 6 squares? That's what we are saying, but the aliens will have this question, right? Then what about 3 stars plus 3 stars? 3 elephants.
But they won't even be able to count the squares.
One problem, they won't even know what plus sign is. So
Yeah,
this
that is a real basic question, but what I'm saying is that no matter how many examples you give, are you really telling them 3 plus 3 equal to 6, or are you just showing examples of 3 objects and 3 objects?
Yeah, 3 objects in table because that's how they'll understand it. Otherwise, they won't understand it.
Yeah, we hope they understand it. But the question is, we have all seen 3 objects. We have seen 3. I don't know, we have not seen 3 aliens, but we have seen 3 circles. Have you seen the number 3 actually? And ever? We know the symbol we should draw on paper, but is that symbol the number 3 or the idea of 3 something bigger than that?
The idea that we have, it's
Idea.
our abstract idea that makes us numbers and stuff like that.
Yeah, see,
Even
so
notepad.
something like happiness. Yeah, everybody experiences happiness, but can you show happiness? Like in this box, there is happiness. So start to realize that these numbers are like that, but you cannot show them in any way.
And also,
It's like 3 in some other language, some different symbols, like in Marathi, we write 3 like this. These are all symbols to refer to that object, but we can never touch or see or feel that object. We just think that object exists. Okay, so I want to show that picture in this way, that we have what we call the land of objects. There is some mysterious planet maybe where all these objects are living. So that what we call the number 3 is there, but we cannot see or directly interact with them at all. What we have when we write the word or the letter 3, or when we say 3 verbally, we are referring to that object. So what we are just making is a reference to that object. That there is some object called 3 and it has some properties like what we saw here right now. We are never directly able to see the object. we can only make references to that object, that this has this property. So in the same way, the plus sign also is referring to some other object. And what mathematics is the connection between these objects, that this object and this object are related to this one in some way. And that is what we do in mathematics. Okay. Sometimes we don't even know the value of that object. Like in the previous example, T and U, those were variables, what we call, right? We don't even know the values of those variables. So sometimes the symbols we use are like that. So when I write a letter like T, referring to the tens place, that is also referring to some object like that, which I cannot see directly. So you see all of these symbols. So this is the land of label and the land of objects. That is how you can think of it. Okay, so we are always manipulating labels, that I add 3 to 3, subtract 6 from 3, whatever we do, we are always manipulating labels, but the objects are sitting in some other dimension, anything like whatever science fiction analogy you want to use, that some different universe in which those objects are there, which we cannot directly talk to. Okay, so that is how these symbols are for us. Okay. So therefore, we need to use what we call symbols, like variable, like T, X, Y. You must have seen this, right? You will solve some basic equations like 2x plus 3 equal to 5, right? Solve and find the value of X, something like that. So why do we require these kind of symbols and notation? Why do we require these symbols to express it?
Sir, maybe
Because we
because,
don't know the value.
so maybe because like they could be a variable, like how we have x can be stored as a variable, can be stored as a different number. But for us, universally, x could mean anything. But for us, that symbol 3 as means the same thing, 3 all the time.
Okay.
And maybe only because we think it up, just because we think it.
Okay, so Kevin gave one reason that we sometimes don't know the value. Any other reason why you use symbols instead of numbers?
Because when you want to use large numbers like 1 billion, you don't actually have to draw 1 billion circles. It's
Yes,
just like
you don't write all those
1, 0,
numbers.
0, 0. So just draw 1 line and 9 circles instead of drawing 1 billion circles.
Okay, Bharat, you are saying it. Same thing. Okay, yes. So we cannot write a big number. Anything else?
So this is our
There are numbers that somebody can just write zeros or something like that.
Okay. So it's all valid reasons, but let me add one more reason. Yes, Ranmay.
So if we have a number, let's say 3 plus x, but we don't know what is x, but we have the answer which is 12. So we can add different numbers to get the answer. 12.
Okay.
So this is Arush. Can I say?
Yes, go ahead.
So it actually putting variables actually helps in calculations. Like for example, a square minus b square is equal to a plus b into a minus b. We can use that in calculations. I'm just like that's an example.
Right.
So, like there are many more equations that can help us in calculation because you can replace that value of a and b with anything. Like so it actually like doesn't matter what you replace it with. So
when you want to add anything?
Yes, so this is an important concept because in Scratch also talking, I do Scratch, the variables are present, so we can set them to different values and those different values can be used to code.
Okay.
So in an equation also, because we have x, a square plus b square is equal to like whatever it is, c square, imagine the Pythagoras theorem.
Okay.
Pythagoras theorem. So we can use that to make different values at the same time. That's what a quantum computer does also. It makes different values at the same time.
Okay. Yes. Can you repeat your name? Sorry. David. Okay.
Can we say that we use symbols so we can understand the object?
We can use symbols to understand the object. Yes, that is also true. Here is my reason why I think symbols are important. So, when at the start of the class, I asked the question, how many of you like cricket? Somebody raised their hand. So, who raised their hand? Like, who likes to watch cricket or any sport? Somebody raised their hand. You raised your hand. तुझं नाव काय? अंशुमन. अजून कोणी हात वर केला होता? सिद्धार्थ. Maybe include my or Shamika. Okay. So, see, I can write sentences like this. Anshuman likes cricket. Or maybe likes watching cricket. Shamika, like. सिद्धार्थ like असं मी लिहू शकतो ना.
Yes, sir.
So say suppose I have 40 students in the class, I have to write everybody's name, Anshuman, like Shamika, like etc. So what we can do now is, there is a famous line for programmer that who is a programmer? Programmer is somebody who works little bit hard right now so that he can be lazy in the future. That is the definition of a programmer according to some people. So we have to work little bit hard right now, but that will allow us to be very lazy later on. So let me say that S be a group. So I'm using the word group here, but some of you may know the word set also. But for now I'm just saying group of all. So this S has all the students who like cricket. Is the what I'm saying. So I have to write so much. Why should I write so much? Because now what I can say, why should I keep saying like cricket, like cricket, like cricket? Now I can just say Anshuman, Shamika, and Siddharth are in S. I just said that these three people are in S. And we know what S is. S is all the people who like cricket. So instead of writing 3 sentences, I could do that in 1 sentence and very few words. So by using notation like this, you are going to simplify your next steps by doing a little bit extra work at the beginning. Okay. So that is why notation is important, because as we keep going ahead in mathematics, right, we are going to encounter so many different ideas. We cannot write full sentences every time. So we have to shorten it somehow. So to shorten it, one approach is by using some kind of notation. Okay. So that is one way by which you can think about notation.
Sir, I figured out another definition for symbol.
Why?
Instead of, let's just say it's 3, 2, 3.
Okay.
Instead of writing circle.
Instead of drawing 3 circles, I can just write down number 3. Correct.
Okay.
Yes.
The sentence.
Correct.
That is what into and then
Yeah, correct. So instead of drawing the circles, you can just write a symbol. Yes, Arav. Yeah, that's actually a very important point. Nobody thought about this. How do you draw -3 circles or -3 aliens? So we run into some problems, right? Ulta. तो and half aliens म्हणजे काय एकच हाफ दाखवणार नुसतं डेव्हलप दाखवायला उलटा सर्कल बेसिक प्रॉब्लेम. So you need yes, Devika. We can make the object half. That will be like a half circle. That will be 1/2. But how you will show -1/2?
Sir, object से पहले minus at the start.
But then
What is minus?
they should know what is minus. So you see, there are so many problems which get solved once we start using symbols. Okay. So that is how we use symbols, and then that also allows us to do something like, for example, everybody knows that 1 + 2 is equal to 2 + 2. Everybody knows that. Way more examples, maybe 2 + 3 equal to 3 + 2. Instead of writing like how many such things I have to write, can I just compress all of that into one line? Yes.
A plus B is equal to
A plus B equal to B plus, correct?
Plus
So you
y is
start-
equal to y plus x.
Yeah. So when you write A plus B equal to B plus A, inside that there are so many infinite information that are communicated in one line. Just by saying A plus B equal to B plus A, you are saying so many things without saying them. Okay. That is why notation is useful. But just because we observed same problem, 2 cases of 1 + 2 equal to 2 + 1, can we be sure that it will be always true? Are you sure?
or addition.
Why? So this is the question now.
Excuse me, sir. I
Yes.
heard at one point that it took 700 pages to prove 1 plus 1 is equal to 2.
Okay. So, but why does that help us to prove A plus B equal to B plus A? That author of that book may
That is not, that's a little bit higher. That is not, it is, so this A plus B is equal to B plus A. You can use that by, if A and B, they are positive whole numbers, then you can use the symbols again. 2 and then 3. 2 circles and 3 circles is equal to 5 circles. 5
yes,
circles.
but author, just let me stop you for a minute. What you're saying is correct, but that means you're just using examples, right? How are you saying that this is true for all numbers?
So, negative
The
number,
proof.
it
The
will be.
PF.
I would like to say something.
Only for negative numbers, that's what you are saying?
Sir,
Maybe, I don't know, because let's first focus on just positive numbers also. Negative numbers will come back to it after, but even for positive numbers, there are so many cases to check. So how can we be sure? So let's do one thing. Can we show addition in like some picture? Like let's say we have an object. Okay? So the length of that object we can call A. Let's say, okay, or maybe some other variable we call it X. Okay. So this is the length of this object, and you take some other object. Okay, take each. Why did I do that? You'll understand. Okay, so my name is S plus H is equal to H plus X. That is what I feel should happen, right? If S has some two numbers. So if you put the X like this, then the total distance is what we call S plus H. Now suppose it happens that you take this stick here and you first draw the H here. And then you draw the S here. Suppose there, it will just reverse in like that, the length suddenly becomes shorter. Shorter? One hand. We किती असं करून बघितलंय? Did you ever try this? How do you know it will not happen? The object is made of what? What? Any metal.
Sir, it will not happen because the object has a definite shape. Shape and
So when I move that object, its shape does not change. You are sure about that? Shape length won't change.
The length does not change. It stays S. But that's what we're trying to prove. The length is now H plus S. But it's the same length.
so this
The same length, still you just switch the order, but
One
the
minute.
now total is now H plus X.
but if I reverse this,
Arthur, just 1 minute. Let me hear what others are saying. Yes.
if we reverse it, the length will be same.
No, that's what you're saying, but maybe you can do this for these two pencils, but any other object of any length, how can we be sure? Okay, so let's say, suppose असं झालं काहीतरी चुकून आपण की खरंच ही लेंथ कमी झाली. Okay, so then what are we saying that S plus H is greater than H plus X? S plus H is greater than H plus X. So this type of yes case मध्ये काय करायचं? So now let me see if I can learn to use this tool properly. आता पण मोठा आहे.
H plus X.
H plus X मोठा झाला पण आता पण म्हणतात की H plus X मोठा आहे. तर जस्ट त्या दोन याच्याकडे तुम्ही इथून बघता का तिथून बघता तुमचा आन्सर चेंज होतं असं नसतं कधी.
Looking at the diagrams are not to scale, but they would be the same length.
No, this is a diagram, but if you take two actual sticks and place them on the the ground, and if you just walk around the stick and look the same diagram from this side, suddenly your answer is going to change. That cannot happen, right? So do you know why I recited that ABCD now? I wanted to choose two letters which took the same from both sides. So S and H were the two letters. So
So you could have used X as well.
X but the Y नाही काढलं. X आणि काय होतं ना आपला X असतो तो असतो that is X and Y. X I would have to use some O or to use some letter like that. But here like a magic trick. हे उलटा केलं तर suddenly now I'm saying that S plus S is smaller and S plus S is greater. So this cannot be true that your answer changes based on which side you look from. So therefore the only possibility is की असं नाही म्हणत तरी ते same lenses पाहिजे कायम. So this is not a proof, but this is like an explanation that you can use to understand something better than just memorizing. Okay. You just because we think it will happen is different, and now we have some understanding की असं काम होतं. Okay. So this was about sum. What about product? H into H केलं तर काय होईल? परत 2 into 3 equal to 3 into 2.
Oh, sir.
Okay. तसंच 3 into 4 equal to 4 into 3. असे किती ट्राय करत राहणार?
So, sir.
इन्फायनाइट ड्रॉप पण इन्फायनाइट हा एक वेगळीच गोष्ट आहे. आता आपण फायनाइट गोष्टीबद्दल बोलतोय. पण इन्फायनाइट जर घ्यायला अजून इन्फायनाइट लेक्चर्स लागतील आपल्याला. म्हणजे आपल्याकडे 5 दिवस आहेत. पण if you are thinking of some question, that's good. So what you can do is, whenever you have any question, I don't want to stop you from thinking, but you can always take it with me offline. Okay, so you write something in your notebook. I am always available any time of the day. You can, send your WhatsApp message with anything that you write. I'll be happy to take a look. So, what about product? In the same way, if I ask the new question about product, okay, so I don't do S now. Maybe A. Why is this true? Again, you can take 2 examples, 2 into 3, 3 into 1. How can you be sure about general case मध्ये काय होणार? So just as for addition, we come up with some like visualization that placing 2 sticks like that is addition. For product, can you think of some visualization like that?
Sir, actually,
Like some example which will show product. Yes, Aro?
Sorry.
No problem. पण इतर लोक असं काढतात की A आणि B ला पण असं होईल. त्याच्यात तुम्हाला तीनचं एक्झाम्पल दाखवू. A आणि B ची व्हॅल्यू माहिती नाही आपल्याला. तर का होईल किती करायची? So Aro drew a picture of 2 into 3 equal to 3 into 2. Okay, by like showing 2 boxes of 3 objects each and 3 boxes of 2 objects each, and they are equal in length. But what about A and B?
Generalize it.
Generalize what? What is the meaning of that word generalize? So easy word to say, but it means so many things.
After you find the example, find the generalize number.
Why don't we do this? Suppose I take a rectangle.
And then you have A and B.
What should the sides of that rectangle be?
E and B.
A and B, area of the rectangle width into breadth or length into breadth. So if your rectangle is of side A and side B, then we know what is the formula of that rectangle. The area of that rectangle is A into B, correct? So area. The same goes to करायची. You can look at the rectangle from 2 sides, right? आता आपण असे बघतो. If I rotate the rectangle 90 degrees, that rectangle will start to look like this. This side will be A and this side will be B. So now the area is B into A. So एका साइडने बघितलं तर area A into B आहे, दुसऱ्या साइडने बघितलं तर B into A. So what do you think we can say?
They are equal because the rectangle only has one area. They are equal.
See, they are drawn 2 into 3, but 2 into 3 6 है ना? So 6 is not there in your diagram. So how will I understand that 2 into 3 equal to 3 into 2? What you can do is instead of drawing them in a straight line, will you draw 2 here like this? 2 here and 3 here. असं केलं तर कसं होईल की ऍटलीस्ट फ्रॉम दिस साइड टू सी इट इज अ ग्रुप ऑफ 3 ऑब्जेक्ट्स लाईक दिस and if you see from here it is a group of 2 objects. That is one way of looking at that water problem. Okay. So we can think in terms of these objects arranged in the grid. Instead of that, I am saying look at a rectangle, and the area of that rectangle should not change if you look at it from this side or that side. Correct? Okay. So therefore, A to B is equal to B equal to. Again, this is not a proof, but this is some way of understanding with logic. Okay. How to convert this logic into proof is something that we'll see in 3 lectures down the line. Okay. Right now, I just want us to start thinking logically that just because we find a few examples, we cannot be sure that the examples will always continue. Okay. We have to try to find some justification in our own words why that property will be true. Okay. So let's start building on this. As I said, that we always ask new questions. Okay. These are very simple formulae. Does anybody know any other formulae? Like distributive law.
Distributive law. I'm writing in the chat. A in
Anybody else has heard of this distributive law? Catch it up, so A into B plus C.
That's because you're opening the brackets, right? Because you're opening the brackets.
त्याला distributive law म्हणतात नाव माहित नसेल कदाचित. But why is it called distributive law? What is distributive about it? We are distributing this multiplication and 2.8 here and 2.8. We are distributing this multiplication to both of them. That is why it is called distributive law. Again, same question. How can you justify this with some diagram? Can you draw some diagram? की त्या diagram कडे बघून हे true असू शकतं असं वाटतं. And now you know how to think of multiplication as area, and you also know how to think of addition, right? By putting the 2 objects together. So how can you combine multiplication and addition both in the same question now?
rectangle.
Thank you.
You get 2 rectangles, both with one side length of A, and the one of them has a side length of B, one of them has a side length of C. Then when you join those rectangles together, get A and then B plus C for the combined rectangle. It's the same size as the 2 rectangles you started from. So that means A into B plus C is equal to AB plus AC. A into B plus A into C.
So yes, Atharv, you had the right idea, and Arav also has the right idea. Anybody else? Yes. Okay, मला अजून problem काय आहे? The problem is this, that you have shown it in the diagram, but why is it true? That I'm not able to understand from the diagram. Instead of writing symbol, you have shown 2 squares there. But why is the property true? So you must have heard Atharv mention rectangle. So did that give you some idea? Who's the rectangle card? Which rectangle? नहीं करना है ना? नहीं, but diagram में करने का नहीं करते हैं. Try तो कर. See what we saw A into B म्हणजे काय? भाई plus circle this way. A into B. For that we draw a diagram in the previous page, right? What was that diagram for A into B? We draw a rectangle, right? And the rectangle's area is what we call A into B. तसं A into C चं काय होईल? How can you show A into C as a diagram?
सर ओमेगा दुसरा लेफ्ट दुसरा ब्रेडचा रेक्टँगल काढायचा आणि मग ब्रेड जे आहे त्याला बीच्या रेषी सी टाकायचं.
हा करेक्ट. म्हणजे असं इथे दुसरा रेक्टँगल काढणार मी किंवा करेक्ट.
फक्त ओमब्रेड वेगळी
फक्त हा हे लेंथ
तेव्हा आपण बी वाली साइड एक्सटेंड करू शकतो.
साइड एक्सटेंड करतो. तो आपण एक काम करूया बाजूला वेगळा रेक्टँगल काढूया. ओके. सो व्हॉट इफ आय ड्रॉ रेक्टँगल हिअर ऑफ साइड A into C. आता काय झालं? These are two rectangles A into B and A into C. What is the connection of these two rectangles with our question?
सर मोठी रेक्टँगल्सच्या एक जी लेंथ आहे that is A. Length of breast is A.
Yeah, this one side is A, correct. But we are interested in justifying this. Why is this distributive log 2?
सर कारण तुम्ही A हा B सोबत पण मल्टिप्लाय करता आणि C सोबत पण मल्टिप्लाय करता आणि मग त्या दोघांना ऍड करता.
Okay, ते तर तिकडे करतोय पण डायग्राम मध्ये काय करतोय? How do you add two things in the diagram like that?
दोन्ही पण रेक्टँगल जॉईन करायचं.
Turn करायचंय. What if we join these two rectangles by if I just let me erase this A from here for a minute. And if I just move this rectangle, are they forming a one big rectangle now?
Yes, sir.
And what is the area of that big rectangle? Sir?
AB plus AC.
I mean area of individual rectangle.
So we are finding the area of that big rectangle. I won't draw the rectangle here, but I'm just marking the corners. So everybody understands which rectangle I'm talking about?
Yes, sir.
So that big rectangle area can be written in two ways now. One is we apply length into Z for the whole rectangle. So what will you get? A into B. And what is another way of finding the area? You add the parts. So you add this plus this. And that will also give you the area. So if you are finding the same area in two different ways, they have to be equal, correct?
Yes, sir.
So therefore A into B plus equal to A into A. So you see how diagram can show a property. What about B plus C and B minus C? Suppose I ask you the question A into B. That's answer काय?
सर ते सी छोटा
A into B minus A into C.
AB minus
AB minus. Correct. So it is A into B minus B. Again, the question is that can you draw diagram to just
Excuse me, sir. I know it makes no sense, but you can just
let
consider
everybody
the
try.
minus C.
Atharva, let everybody try, okay? So if you get the answer, you draw it in the notebook and I will take a look. Everybody copy this down if you understood it. And then think of A to B minus C. That's a kind of.
Let me see.
This is A, this is B minus C.
What's the question is sent out?
This is B. Then it will be B plus C. Here will be B minus C.
I don't know what the question is.
खाली पुढ्यात काही प्रश्न व पक्ष्यांचे राहण्याच्या जागा लपलेल्या आहेत ते शोधा आणि त्यांची नावं लिहा. Names of some animals' houses are hidden. Find it.
Animal houses.
Houses and birds.
Houses and birds.
Yeah.
So in all cases, right, you are taking the example of 2 and 3 only. But in my example, do you see I am using the number 2 and 3? Because see, then I can ask for very big number, like 100 and 200. You cannot draw 100 boxes, right? So we need some method where we don't need, that number is not important, whether it is 3 or 300. That number should not matter. So can you try to show the same diagram in a way where that number A is not important? This number 3 is not, the 3 can be replaced by A also. Now,
9 and 10. We already did 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 has to be the next book.
Actually, this next part can be nice. So this part.
Excuse me, sir.
Yes. Who is speaking? I'll come to you.
Heart.
Okay, so many people have figured it out that now.
Yeah.
So I think many of you have figured it out.
So, excuse me, sir, just substitute C for the negative C.
Yeah, but then how will the diagram look like? Because what is a rectangle with negative C as one length?
No. Okay, there is no rectangle, but you have already proved the previous statement.
But then instead of doing that, what I am asking is, can we find a new visualization for the new statement? So most students have drawn something like this. First, starting A to B. So A to B is a rectangle concept. And then inside that you draw a rectangle with length A to C, correct? So you take a segment of length C over here and you draw this part. And now which area we are going to calculate in two different ways? This part, right? The right hand side part. So because this is C, so this length is B minus C. So you can find that area by directly applying the formula for this. So you'll get A into B minus C. Or what can we do? We take the entire area and त्याच्यामध्ये हा count झाला आणि हा पण count झाला ना. So we have to remove this portion. So if you do that, you'll get AD, which is the whole area minus that part, which is A square. Okay. So we are finding the same area in two different ways, and that is why we can equate it. आणि असेच तुम्ही शाळेत भरपूर फॉर्म्युले शिकणार आहात. These are just the starting points. Any formula you learn in the school, can you see how to convert it into some diagram like this and see if that can be used to justify the property which you are looking for. So for example, let's just take one last example here. So how much is A plus B into A plus B? You know this?
A square plus 2B plus B square.
A square
2AB plus B square.
2AB plus B square. That is what we see.
Sir, A plus B square.
But the expand here तो कैसे काय formula है?
I'll do that. 5 minutes.
पण त्याचा
मी पुढे
म्हणजे पूर्ण एक्सपांड केले सगळे टर्म्स दिले तर कसे दिसतील ते?
A squared plus 2ab plus b squared.
That is what somebody is saying. Atharva is saying that. But now I'm asking that can we draw a diagram which can show this? Suppose we don't even know the answer. Okay, let me just erase this part. We want to find a plus b into a plus b. So, what diagram can I draw to come up with this answer?
Make
See,
a
if you
square.
understand this method, what will happen is that you will know the answer before the teacher tells you the answer. So while waiting for the teacher to come and tell you what is the answer of this formula, तुम्ही स्वतः शोधून काढला तर? So can we draw a diagram in which a plus b into a plus b can be drawn like a picture?
Yes, sir, we can draw a line. Because it's plus, it can be a line.
Yes, but the whole
That
formula
line
a
into
plus
I
b
and line will be square.
the whole formula a plus b into a plus b, how do you show in a picture?
Yes, I was saying we can make a line and then we can and because those lines will be the same thing, it will become a square. So that square, which is a square, there will be there will be one smaller square, which will be a square, one other square named b square, and then plus 2 into a into b, which would be another bigger square, and we can add them all up in a very big square.
Yes, Athar. I think at least I'm not able to see the diagram, but I understand which picture you are mentally painting. So that is correct.
A plus b into a plus b is a square. A plus b. No,
Yes.
a plus b.
Yeah, right. This is the whole square. But now, how can you? This is a plus b, right? So can you divide it into parts? A and b as a whole.
So a plus b. I can't show the others.
1 minute.
A plus b.
This is b.
Make a square. A plus b side length of a plus b and side length of a plus b.
नाही पण रेक्टँगल मध्ये टू ऑपोजिट साइड ऑफ इक्वल आपण दिस अँड
Side length of a plus b. Square with the side length of a plus b. Area is a plus b into a plus b. It's the
If you draw a square, in one side other side of the square. So let me help you with something that we are again multiplying two numbers. So what we should do? We should construct a rectangle or a square actually, because here both numbers are equal. त्यामुळे तुमच्या रेक्टँगलचे लेंथ आणि ब्रेड्थ इक्वल असतात. Correct?
square with the side length of a plus b.
Yes. So we have a square whose side is a plus b.
Now out of that a plus b, some length will be our a.
आता पुढे काय करायचं? त्याचं करेक्ट. पुढे काय करायचं? So you can find the whole area
Sir, I got it.
by adding all the parts.
I think I got it. I substituted a with 2 and b with 3. And when you did the whole equation, you got 25. So a square plus b square plus 2ab is 25. And because you want to make that into a square, you square that 25, which is 625. That means the whole square will have an area of 625.
That
Yes. But Kavin, the problem is that is working for 2 and 3. What if I change the numbers? I would like a method where all numbers I can conquer in one step, right? I don't want to try every possible numbers one at a time.
Yeah, but that will be a very big number if you change the numbers.
Yeah, it will be very big to try all the numbers, right? But
Yeah, so-
are you looking at my board where I have drawn this?
Yeah, I've seen. Yeah. Yeah.
Square. Or you can take one more view from me. What will you do after that? So we draw, everybody is drawing this square inside it. What after that? What will be? Okay, so let me help you if you are stuck. Why don't we split this side A plus B into two parts, A and B? असं करू शकतो ना आपण. I can mark a point here. So this length is A and this length is B, correct? And on the vertical side also, I can split that A plus B into two parts, correct? This part is A and this part is B. And now if I draw these lines, so now I've divided my square into four parts. And let us do the same thing that we did before. We can find the whole area of my square by side square, right? So side A plus B है, क्या मैं A plus B square is the area of my whole square. I can also do addition of all the four parts. A plus A plus A plus हे केलं तरी आन्सर येईल. So आता प्रत्येक पार्टचा एरिया काढायचा. So हा पार्ट काय आहे? This part has length A and breadth also A. So this is actually a square of length A. So या पार्टचा एरिया किती येणार? A square ना? A square. What about this part? B square. This is also B. This is also B. So this is B square. आणि आता उरले कुठले part? This is
AB.
AB. And this is BA or AB. We can write AB also here. So total किती झाले?
Square plus 2AB plus B square.
A square plus AB plus AB plus B square. Or in other words, A square plus 2AB.
Understood, sir.
Close झालं. Last step बोलली होती. But method कळली का की how can instead of somebody telling me the formula, we found the formula. त्यात काय कठीण होतं? स्क्वेअरचा एरिया सगळ्यांना येतो, रेक्टँगलचा एरिया सगळ्यांना येतो. सो सगळं आपल्याला येत असतं, पण आपल्याला कधी ट्राय करायला चान्सच देत नाही. So that is what you have to look for your own. Okay, so what do you think my homework for you will be?
So I think that we just have all you have to do
Your
is
simple homework हो तर मोठा ह्या इक्वेशन वर ना एक अजून एक क्वेश्चन सुचतोय का? A minus B. A minus B square चं काय म्हणजे तुम्ही घरी जाऊन विचार करा. Okay, see if you can find the answer of A minus B square on your own. स्वतःहून जमलं तर आपण ते डिस्ट्रीब्युटिव्ह लावलं तर हां डिस्ट्रीब्युटिव्ह लावलं तर तसंच काहीतरी करायला लागेल ना. पण एकदा करून बघा घरी जाऊन जमतंय का. So A minus B square can also be done in the same way. Okay. पण आता मला तरी वेगळं सांगतो म्हणून मी आता तुम्हाला वेळ देत नाही करायला. So from this question, which other questions you can think about? That is the question. Nine. Can you write down what you are saying? Okay, so you can think about a minus b square on your own. But now I want to ask you a different question. What if I multiply a plus b into a plus b into a plus b 3 times? Just like we did powers of 3, we can do powers of a plus b also, right? So what about a
That
plus
is going
b?
to be a cube, and we have to draw a cube. You know,
If not
that is a cube.
So that whole square will be multiplied by a into b.
So
That whole
everybody
square.
understand की when दोन नंबरचा प्रोडक्ट होता तेव्हा स्क्वेअर काढून चाललं. But now we have to multiply 3 quantities a into a into a, which is a cube. So will area be useful? No, we have to think about volume, right? You understand the concept of volume? 6 पॉवर very valid question. पण आपण आधी थर्ड पॉवर सांगतोय का बघूया. पण नंतर 6 पॉवर कडे पण येऊया. So we need to draw a volume of side 3. म्हणजे असा क्यूब काढायला लागेल ना मला. तर काहीतरी करायला लागेल. ते हातावर जाईल. ह्या साईडला घेऊन चालत नाही त्याला. बोर्ड असेल सोबत बोल. It will be so difficult to do this now. So again, let us take help from some magic. Okay. And so I'm trying this for the first time, so I don't know whether it will work or not. But try to go here.
Sir, about the cube का net cube करू काढू शकतो. Right.
The cube काय?
Net cube.
नेट काय असतं?
Cube that's
ओपन करायचं. पण त्यांनी व्हॉल्यूम काढायला कसली मदत करेल? पण ओपन केला तर तो फ्लॅट सरफेस होणार. मग व्हॉल्यूम उरलाच नाही. आपल्याला व्हॉल्यूम काढायचं आहे. Let's try this now. Okay, this is a complete experiment, and I'm very curious to see whether it works or not.
Sir, I got the homework. The homework is solved.
Okay.
I solved.
So any homework that you solve, send it to me on WhatsApp, and I will give you homework because there is
I
no
solved the
homework in your MD.
Yeah, solved already.
Let us draw a cube. We have tools that you can draw a cube. Okay, so I drew a cube in this software called GeoGebra. Just to make better figure of it. It looks funny, no? But it's not like this. Any idea? Well, let me share my screen for those who are. Okay, so online people, can you see this cube now?
Yes,
sir.
This is very funny cube. Do you see?
Yes, sir.
Colors का mix this type.
Excuse me, sir, there are 2 layers. This is layer 1, layer 2.
हाँ.
सध्या छोट्या छोट्या मध्ये
क्यूब है ना 3D है ना हम 3D डिस्कस है and you can get it on top of the glasses doesn't matter. Take it. And for those who are watching this online, unfortunately you don't have the glasses with you, but they are very cheap to buy. You can make it at home also. It's not very difficult. Okay, so you can buy them. I'll share this file with you so that you can watch this at home. But this type of file. Take a few this time. Wait a minute. Correct.
I can see 8 and 27. I can see 8 and 27. Those are cubes. 2 cube, 3 cube.
नाही 3 डायमेन्शनच आहे. सो आपल्या डोळ्यांना असं 3D का आत येतो?
So, sir, can you read this?
Yes, yes. Can rotate it. In fact, take it home and draw your own 3D pictures. थ्री जॉमेट्री करायचं तर 3D दिसलं पाहिजे ना. तर अजून एक बॉक्स होता ना, मी पण बघतो. So we are solving the question a plus b bracket cube. So we need to see a cube whose side length is a plus b. आणि त्या a plus b cube चे आपण आता तुकडे करणार. So in this diagram, you can see this whole length is a plus b, and in the middle there is a partition. So one part is a, one part is b. That is how it is done. And right now, see, after you make the part, right, there are so many parts. So सगळं एकदम बघणं शक्य नाही. म्हणून मी काय केलं की त्याचे मी लेयर्स केले. So at a time आपण एका गोष्टीकडे बघूया. So let me switch off everything. Let me just keep the a cube plus b cube term. Do you see two cubes now?
Yes, sir.
This is a cube and this is b cube.
Yes, sir.
Okay. So आपल्या फायनल उत्तरात a cube plus b cube येणार. Okay. And by the way, एक खूप भारी I think the board is not able to keep up with the frame rate, so it is stuttering in between. But if you watch this at in your home laptop, it will be very clean. Okay, now let me switch off these two cubes temporarily and introduce the next layer. Okay. So आता इथे आपल्याला तीन त्याला क्यूबॉइड म्हणतात. Do you know the word cuboid?
Yes, sir.
It is not a cube, it's a 3D object. आणि आता ह्या क्यूबॉइडचे लेंथ
Like a rectangle in 3D. Like a rectangle in 3D.
It is like rectangle in 3D. So now if you see this part, right, then the one side is 2, height is 3. So 2 cross 3 cross, आता हे thread दिसत नाही म्हणून तो रोटेट करता आला पाहिजे. So let's rotate this diagram. आणि ह्या साइडने बघूया. So this is 2 cross 2 cross 3, correct? So that is our a square b term. आणि असे तीन आहेत. तुम्ही घरी जाऊन बघा सगळ्या साइडने ते इक्वल आहेत. ओके. सो a square b ही टर्म तीनदा येणार. ओके. And finally we have उरलेले तीन क्यूबॉइड which will form ab square. So असे आपल्या क्यूबचे 8 पार्ट झाले. 8 parts. A cube, b cube were 2 parts. A square b चे 3 parts आणि ab square चे 3 parts. So that is how we got total of 8 parts in our cube. So let us switch on everything now. तर आता मला अजून एक गंमत दाखवायची. हे तर मी here I chose a as 3 and b as 2. Okay. But I may want to try for different values. So can I change a and b and the diagram will automatically change so that the curve varies?
Yes, sir. That's how it works.
Change the value of a and you see the diagram is changing. मी a छोटा केला की हा पार्ट तसा छोटा होतोय. a वाढवला की हा पार्ट तसा मोठा होतो. आणि तसंच b बदलला की पण डायग्राम बदलतो. तो हा थोडा छोटा मोठा सगळं होईल. असं का करताय तर मला देऊ नो बिकॉज हे जे पॉइंट्स आहेत ना ते पॉइंट्स तर मी नंबर नाही देते की हा 2 आहे हा 3 आहे. मी सिम्बॉल्स मध्ये बोलतोय. आय इफ आय जस्ट गो अँड डिफाइन शो यू हाउ डिफाइन द पॉइंट्स. सी द कोऑर्डिनेट ऑफ दैट पॉइंट इज नॉट 0 0 2, इट इज 0 0 a. So when I change a, that point automatically changes. When I change b, automatically a different point changes. So but just by changing a and b, I can change my diagram if I want. So आपण Excel बघितलं की how Excel can be used to help mathematics. This is one more tool which can be used to help mathematics.
GeoGebra.
GeoGebra, correct? Okay, so I'll stop sharing this screen for now. And you can remove your glasses, you can take them home. Perfectly fine. Okay, now one more thing to observe before you keep the classes. आता 5 मिनिटं आपण glasses घातले ना, एक डोळा बंद करा आणि सगळं जग बघा. Close one eye, remove the glasses, close one eye, close your right eye and watch everything with your left eye. काय दिसतं? सगळं निळं दिसतंय का? उलट करा, close your left eye, watch everything with the right eye. सगळं लांब दिसतंय. तर डोळे बिघडले की काय आपले? Don't worry, you'll be back to normal in 2-3 minutes. And interesting thing, with your left eye, you are seeing the world as blue, but actually the left lens is red. Oh, that's right. Well, do you know how this 3D software works?
No, sir, I don't have the glasses.
Don't see, if I hold this close, you'll see what is happening. Through the red lens, I can only see half the picture, and through the blue lens, I can see the other half of the picture. So your two eyes are being shown two different pictures at the same time, and that is what pulls your eye into seeing that there is a 3D effect. पण या गोष्टीचा विचार करा की लेफ्ट लेन्स रेड आहे तर त्यांनी जग ब्लू का दिसतं आणि राईट लेन्स ब्लू आहे तर त्यांनी जग रेड का दिसतं. त्याच्यामध्ये पण भरपूर मॅथ्स आहे जे आपण या 5 दिवसात नाही करू शकत. But you see, you do one thing and you don't stop there, you ask more questions. But for that, you have to be, consciously observing. If you don't observe, you will not get the data and then you will not think of questions. So you have to keep doing this. Okay. But I think that is we are almost at the end of our time. So that was the question of a plus b whole cube. So now we can write the formula by this intuition. Again, this is not a proof, but this gives you some guesswork करायला काहीतरी बेसिस तर पाहिजे. Okay. So now we can write our formula a cube plus
A cube plus b cube plus 3a square b plus 3ab squared.
There is on convince yourself की ते खरंच आहे. आता कसं मला 5 मिनिटात घाई करायला लागेल थोडी, but take your time, observe that cube from all different directions and मी म्हणते म्हणून खरं नका सांगू. Go home and check it for yourself. की खरंच आहे काय.
Excuse me, sir, you didn't send the link.
I'll be uploading all this material to the website, and once you sign in, you can see the material. Okay. Once this lecture is over, give me 1 hour. I'll go home and upload it. Okay. So, but तुझा पुढचा विचार करायला लागला आणि लगेच विचारलं 6 पॉवरचं काय करायचं. 6 पॉवरचं काय करायचं. 3D classes तर आणले, 6D classes कुठून आणणार. I also don't know the answer, but काहीतरी तो सोल्युशन काढायला लागेल. So you think की आता a plus b क्यूब तर काढला, a plus b raised to 4 काढता येईल का. त्याला कुठला चष्मा लागेल. तो चष्मा बनवता आला तर घेऊन आहे. We'll see how to do it. In fact, we are going to see a plus b raised to 4 in a different way in the last lecture. 10व्या लेक्चर मध्ये बघणार. जेव्हा आपल्याकडे प्रोग्रामिंगची पूर्ण ताकद असणार आहे तेव्हा आपल्याला a plus b raised to 4 पण बघता येईल. पण ते मी आता नाही सांगू शकतो. So, but with that, we'll end today's lecture. So, I hope you enjoyed. Firstly, I hope you not tense नाही झाला की अरे आपण अभ्यास दिला कोणतरी थोडं रिलॅक्स होण्यासारखं वाटत असेल तर that is one objective I hope I have accomplished. And one more important thing I have observed through this is की आपण algebra करत होतो पण मध्ये geometry असते. So everything is connected. Algebra, geometry, number theory, these are not like separate topics. You will start to see the connection between all these topics. And त्याचा तुमचा अभ्यास करायला फायदा होणार आहे. Because if you learn only algebra as a subject, but you don't connect it to geometry, you will have to memorize 1,000 things. But once you start seeing the connections, the burden on memory will be less. Okay, so this is how you can approach any subject, even languages for that matter. Okay, so we'll see more examples of this in the coming days. But for now, I think that's all. Thank you. I'm ending the meeting now. Thank you, everybody online. Bye.
Thank you, sir.
Sir, where can we find the recording of this session?
Yes, sir.
I will put it on YouTube and I'll send the link on the WhatsApp. Okay. Okay, bye.
Okay, sir.
Bye, sir. Yes, sir.
Sir, and bye.
Yes, sir.
That was fine.
Well, हे मला जरी कोण दाखवायचं होतं समोर ते राहून गेलं ते पाठ लावून. What I was explaining that why can we use why notation is powerful. This is something I found internet. मला माहित नाही खरं का खोटं. But the claim is that these two lines of equation describes all the physics in the universe. That is the claim. Yes or no? This part is the one which is showing of gravity work. This part is showing काय quantum mechanics experiment काय त्याला कळत पण नाही काय लिहिलं. But एवढ्या कमी जागेमध्ये एवढी माहिती कशी कोणता आली तर नोटेशन मुळे ना या प्रत्येक सिम्बॉलचा काहीतरी अर्थ आहे तो अर्थ समजायला आपल्याला 4-5 PhD लागते तो वेगळा प्रश्न आहे बट द फॅक्ट दॅट यू कॅन यूज नोटेशन टू कॉम्प्रेस इन्फॉर्मेशन लाईक दिस दॅट इज अ व्हेरी व्हॅल्युएबल आयडिया मला पण नाही लिहून ठेव पण ते लिहून ठेवल्याने कळत असं थोडी आहे नुसतं नोटबुकला कळलं आपल्याला काय कळलं हा चाल व्हॉट्सअप बट डोंट मला हे खरं आहे की कुठं हे पण माहित नाही मी जस्ट नेटवर सापडलं तर मी इमेज कॉपी पेस्ट केली येस